All right, hey gang. I'm gonna get right into the homework for today. Just letting you know I don't feel very well, and so I'm gonna try to work our way through this. Yeah, if you have any questions, I'm gonna try to answer all your questions right here in real quick. So first thing I want to do is I'm gonna pull up the actual homework sheet here, and you can always pause this at any time to look at the questions a little bit more carefully. But I'm going to kind of walk through each of these real quickly for you so you can see how you should went about answering these questions. So let's get right into it. Starting with the questions from page 651. We had numbers 55 to 60. And I know this is not the best lighting, so I apologize. I'll try to get that to be a better image. Good, there we go. Okay, so in this first picture right here, we want to try and figure out what the circumference is. Now remember what circumference is. It's pi times diameter. And so if I can figure out what the radius is, I can find the diameter and I can figure out what pi, what the actual answer is going to be. So for number 55, what is the radius going to be? Well, this is a 45, 45, 90 triangle. How do I know that? Because the radii are both congruent. It's a right isosceles, makes us a 45-degree angle here and a 45-degree angle here. So what we have, maybe I can get this down a little bit further. What we end up having here, if this is x radical 2, the hypotenuse, this side is x and this side is x. If this helps as a visual, x and x radical 2, we know the hypotenuse right now is 4 radical 2. So what is x? Well, x is 4, okay? So as a result, the diameter, since the radius is 4, the diameter is going to be 8. So the answer is 8 pi, but then they want you to do the circumference nearest hundredths place, which again is 2 places after the decimal. So you can see the answer there in Schoology again. Down here, this length is 3, this length is also 3. So I have a portion of a right triangle. This is 56. A portion of a right triangle. We want to figure out what x is going to be, this length at, oops. We want to figure out what the length is at RQ. And so I'm going to make that x. We know that this length is 3 because it's a radius and so is this one. And remember, this whole figure was a square. So that means that this angle is a right angle and that this length is the length of this whole diameter here. So that's a length of 6. So you're going to set up your Pythagorean theorem, 3 squared plus 6 squared equals x squared, and you're going to go ahead and solve for x from there, okay? For number 57, it says here that in the picture figure, C is the midpoint of AE, so C is halfway between A and E, okay? Now AE we're told is 32, so I know that AC is 16 and CE is 16. B is the midpoint of AC, so that means that these are both 8 and 8. And D is the midpoint of CE, so again this is 8 and 8. So as a result, we want to find the circumference of circle C to the nearest hundred. So remember, this was 8 and this was 8. So for number 57, okay, the diameter is 16. And so if you type that in, 16 pi, now again, nearest hundredths place, that's 2 places after the decimal. Make sure you round correctly there, okay? For number 58, let's take a look there. 58 is right there. Okay, make that better. Okay, so we have a right triangle, those two side lengths, and it's inscribed. It says, which of the following is the best estimate for the circumference of circle M? Well, the first thing I'm going to do is I need my diameter. So if I do 11 squared plus 20 squared equals, let's say, d for diameter squared, you can go ahead and solve for the diameter length, okay? Now, when I do that, let's actually work that out here real quick. So for number 58, okay, 11 squared plus, what was it, 20 squared? Say it's d squared, so this is 121, this is 400. And so this is, what is that, 521. So the diameter is going to be the square root of 521, okay? So to get the circumference, you can go ahead and just plug that into your calculator, square root of 521. We're going to multiply that by pi, okay? And so from there, according to the book here, it says it's going to end up being c, and you can go ahead and type that in. Again, the square root of 521 times pi, and that should give you that same answer, okay? Number 59, some of you had some troubles drawing this out today. So number 59, here's what we have. Oops. There we go, about right there. Okay. In number 59, it says square JKLM has an area of 9 square meters. Okay, so before I do anything with number 59, I'm going to draw myself this square. Maybe I'll do it this way. Go up just a bit. So if I do this, the square, JKLM. Okay. Now let's think about this for a second. If the area of all this in here is 9 square meters, what will the length of each of the sides be? Well, remember, area is base times height. And so if I think about it, or side squared, okay, if I do side squared, if I square both sides, the length of each side is going to be 3, okay? So we end up with 3 and 3, just to be aware of what's going on here. Now it says a circle with the center M passes through JL. So this is my center point, and so the circle passes through those 2 points. So what we end up having is something that looks kind of like that, okay? Now, let's see here. Part A says name the circle. You can see that circle M. We always name the circle by the center point, okay? Name the line segment that is a radius of the circle. Well, that'd be JM or ML. Either of those would be radii. And what's the circumference? Now, the circumference, remember, is going to be, let's see here. What is the circumference of the circle? Oh, let's see here. I gotta check something real quick. Circle passes through J and L. Interesting. I don't think the answer is 3 radical 2 pi. The answer should be 6 pi, okay? The entire diameter, there's going to be 6. So I'm going to go with, for 59, letter C, that's going to be a change in the answer here. It should be 6 pi meters there, okay? So sorry about that. That's again a mistake by the textbook there. So for number 60, as we look at number 60 here, it says triangle DEF is an equilateral triangle with side lengths of 2 inches. Explain how the diameter of circle C, how to find the diameter of circle C. Okay, so here's what I'm thinking. If we know the triangle is an equilateral triangle, so if I go ahead and do this, number 60, what we know right now is that each of these angles are 60 degrees, okay? Now this line right here, that line makes this a 30-degree angle, okay? So what are we looking at? Well, here's our center point. Okay, and so what we're looking at here is this. To find this diameter, and each of these side lengths are a length of 2 inches. So this whole side length is 2. That would make this one 1, okay? And this length right here, you can either do your Pythagorean theorem to find that length, or you can do your 30, 60, 90 triangle rules. Now, remember what the 30, 60, 90 triangle rules were. It was this. Crossing the 30 is going to be your x. The 60 is your x radical 3. And across the hypotenuse is going to be 2x, okay? So we already know that this is 2, that this is 1, so what's this length here? It's 1 radical 3, okay? Now from there, if I'm going to go ahead and find the circumference of that, so let's see here, how do we find the diameter? I would just put that down. It's the 30, 60, 90 triangle is going to allow you to find the diameter. What's the circumference of circle C? We're going to go ahead and do this with the diameter. Circumference is pi times d. And so the diameter was 1 radical 3, so I'll say 1 radical 3 pi, or radical 3 pi, and that'll be in inches. Okay. So, again, that's a 3 there. I know it's hard to read. Okay. So there's your answers to the first half of the homework. The second half, if I go to page, what is this, 660. Okay, here's the first one. It says a model train runs on a circular track with a diameter of 4 meters as shown. Which of the following is the best estimate of the distance the train travels as it moves from the station to the grain silo? Okay, so it looks like the station's at S, the grain silo is at G. So this length right here, remember, we're going to take, let me get another piece of paper on the back side here. Okay. We're going to take that arc measure, which is 125 degrees, okay, this whole thing is 125 degrees, over 360, that's the portion of the circle I'm working with, and multiply that by pi d. Now it looks like the diameter is 4, so I'm going to multiply this out right here, and that should give you one of those 4 answers down there. According to the book, it says it should be C, okay. Number 66, as I look at this in circle, we've got these angles that are congruent, KJL, okay, LJM, and MJN. Now, before I go any further, if these three are all equal and together they make 180 degrees, they should all be 60 degrees, okay? Sophia wants to calculate the length of JN, or LN, this portion right here, okay? So which of these expressions would we require the length? So first of all, the diameter is 12, so it's 12 pi. So I can get rid of all of these except for these two, okay? Now this one will calculate the length. Let's see here. Oh, it's ln, sorry. So we're spanning not just 60, but a total of 120 degrees. So I'm going to go with D right there, 120 over 360 times 12 pi. Oh, goodness. I did that whole problem without you guys seeing it. Okay. So back to this again. So what we read was that each of these angles were congruent, which means that they're all 60 to make 180 degrees. And then from there, the diameter is 12 pi. So if we're trying to find this arc length from L to N, there's 120 degrees there. So 120 out of 360 times 12 pi, or the circumference, will give you the length along that arc. For number 67, in circle B, measure of angle LBM is 3x, LBQ is 4x plus 61. What's the measure of angle PBQ? PBQ. Oh, gotta move this again, sorry. Okay, what's the measure of angle PBQ? Well, here's what I'm thinking. These two angles are supplementary to, or I'm sorry, they're congruent to each other. They're vertical angles, okay? So these two that are listed up here, this one here and this one here, are supplementary. So if I do the equation, let's get this over here, 3x plus, what's the other one, 4x plus 61, and set that equal to 180. If I solve for x, whatever that's going to be, okay, I can plug that x back into this expression right here, because that's the measure of this angle, and knowing that measurement, you can then know this angle right here, because they are vertical angles, okay? So, yeah, that's how I'd work that out. All right, now the next one, let's see here. Okay. Says the table shows the polling numbers for the election coming up. And so if you were to construct a circle graph of the information, what would be the arc measures for candidates B and D? Okay, so B was 30%. So for B, I would take 0.3, that's 30% as a number, 0.3, or 30 out of 100, and multiply that by 360. That will give you the arc measure of candidate B. For candidate D, where's D at though? It's 0.05, or 5 over 100, and again multiply that by 360. That'll give you the arc measure for candidate D. For letter B, if we combine candidates A and B, what would the arc measure? What would be the arc measure? And what type of angle would this be? So if we combine A and B, If we add those two up, that's 62%. So if you did 62 over 100 and multiply that by 360, that would give you the arc measure. Now, if it's greater than 50% of the circle, that means it's greater than 180 degrees. So this is going to be a major arc because it's greater than half the circle. If we combined C, D, and E, what would be the measure of the arc, and what type of arc would that be? Well, C, D, and E, if we had 28, 5%, and 5%, that's going to end up being 38%. Okay, so 38 over 100 or 0.38 either way, and multiply that by 360, and that will give you this 136.8 degrees. Since that's less than 180, you have a minor arc there. Okay. Now, for letter D, are there any congruent arcs in the graph and explain? Well, with these both being the same percentage, candidates D and E, both 5%, they have to be congruent to each other, which is what's stated right there. Number 69, the minute hand on a clock is 3 inches long. Which of the following is the best estimate for the distance of the tip of the hand moves as the time changes from 12:30 to 12:45? Well, from 12:30 to 12:45, that's a 15-minute time span, which is a quarter of the distance around the circle, okay, or a quarter of an hour. So if you were to take 1/4 of the circumference, since it's a quarter of an hour, quarter one time around, let's see here. So that would be the radius of the clock is going to be 3 inches long. So if I do, let's see here, 6 pi, diameter 6, so 6 pi is the circumference, and multiply that by a quarter, okay? Or you could do 15 out of 60, okay? That gives you the ratio of what we're working with of the circumference. That will tell you how far, that minute hand has traveled, the tip of the minute hand has traveled over that course of time. Okay. Number 70. Okay. It says here the length of ST is 3 pi centimeters. What is the radius of the circle? Okay. So if I set this up, the arc length is 3 pi centimeters. And we know that the arc measure is 60 degrees out of 360, multiply that by pi d, or well, in this case 2 pi r. Okay, this is going to be the equation that we solve. Now we usually use pi d here, but since we're solving for the radius, we'll just use 2 pi r. Now, if I reduce this fraction down, that becomes 1/6. 2 pi and the radius 3 pi. Okay, pi's, if we divide both sides by pi, we cancel them out. And so I'm going to go ahead and multiply these two together, so I get 2/6 the radius is equal to 3. Okay. Now from there, if I divide by 1/3, which is the same thing as 2/6, cancels those out. Dividing by 1/3 is the same thing as multiplying by 3. So in the end, our radius length is going to be 9 centimeters. Okay. So again, if you plug that in your calculator because you don't think that's right, make sure you put parentheses around that, and you'll see that it ends up equaling 9 centimeters. Okay. So again, if you have any other questions, I'm sure there's somebody in the class that can help you out. Otherwise, that's the answers and how to get the answers from the homework from last night. Thank you for listening.